So we're going to do the special review exercises. This is chapter 6. Number 1, in one course, a histogram for the scores of the final looked like the sketch below. True or false? Because this isn't like the normal curve, there must be something wrong with the test. False. Right, not everything has to be a normal curve. If, yeah, everybody could get a 0 on the test, and that would not be normal. Okay, number 2. Fill in the blanks using the options below and give examples to show that you picked the right answer. Letter A. If the SD of a list is 0, that means right, every number in the list is the same because there is no variation. We're on 2. So if the SD is 0, there is no spread. Now, I didn't do a very good job teaching you about root mean squared. So let me show you again what root mean squared is. If I had the numbers 1, -7, 8, -3, and 5. Let's make that a -1. If I found the average of those, so -1 plus -7 plus 8 minus 3 plus 5, and then I divided that by 5, the average is 0.4. Okay, but that's not really very representative because we have positive and negative numbers. So we can take what we call the absolute average. We just turn everything positive. Then I take 1 plus 7 plus 8 plus 3 plus 5, and I end up with 24, and I divide that by 5, and I get the absolute value average, I don't know if that's what you'd call it, is 4.8. And that's a better representation of how far everything is away from 0. Okay? But there's something called the root mean squared. So what we do is, instead of taking the absolute value, we square everything. So we go through and we square each of these. So I get 1 plus 49 plus 64 plus 9 plus 25. So 1 plus 49 plus 64 plus 9 plus 25. And now I average that. So I divide this by 2, and then I take the square root to undo the squared. Or wait, or no, not divide by 2, sorry. We want 148 divided by 5. And then we take the square root of that. So in the root mean squared, instead of taking the absolute value, we square everything, and then we average it, and then we take the square root, and we end up with a number that's slightly larger than the absolute value average. Okay, that's called the root mean squared. So we do the same thing with standard deviation. When we calculate the distance from the average, we don't find the average distance from the average. We find the standard deviation, which is just slightly larger. Okay, so the root mean squared is simply you square all the values to get rid of the negatives, then you average it, and then you square root to get the answer. So if the root mean squared of a list is 0, this means so what does root mean squared measure? It's the squared distance from 0. So if the average of the squared distances from 0 is 0, then all the numbers in the list must be 0. Yep, they have to all be 0. Okay, 3. A personality test is administered to a large group of subjects. 5 scores are shown below in original units and in standard units. Fill in the blank. So 79 gives a standard unit of 1.8. And 64 gets a standard unit of 0.8. How are we going to figure out what 52 gives us? Well, what's the formula? What is the z-score formula? Value minus average divided by SD equals the value. So I have Z1 equals 1.8 when V equals 79 and Z2 equals 0.8 when V2 is 64. Okay. What am I looking for here? What do I need to know in order for this to work out? I need the SD and the average. I can tell you something about the about the average. What do I know about the average? It's not between 79 and 64. It's actually below 64. Okay. So how are we going to figure that out? Well, so I know what do you notice here? There is a 1 SD average between 79 and 64. So the SD must be not 1, 15. Okay? So it looked a lot harder than it was. So we know that 79 is 1 SD above 64. So the SD must be 15. Now what do we need to know? We need to find the average. So when I can use either one, let's use this one. It's not 64 minus 15. It's 64 minus 15 times 0.8, right? If I draw my normal curve, here is my x bar, and 64 is right here at z equals 0.8. So I need to come down 80% of the SD. So 15 times 0.8 is 12. What does 12 tell me? Right. 64 is 12 more than x bar. So I just need to subtract 12 from 64, and I get x bar equals 52. And the SD is 15. So what I need the z-score for 52. The z-score for 52 is going to be 0 because it is x bar. Okay. And 72, what should I do? So 72 minus the average, 52. So 72 minus 52. And I'm going to divide by 15. So the z-score for 72 is 1.3. Okay. Now if I start with the z-score of negative 1.4, how do I convert that back into a value? We do this formula backwards, which is value equals z-score times the SD plus the x bar. So I take negative 1.4, I multiply it by 15. What does this number tell me? 21 points below the average, so I add the average back. And the value for that z-score is 31. Okay. Okay. 4. Among first-year students at a certain university, scores on the verbal SAT followed the normal curve. The average is 550, the SD is 100. What percentage of students have scored in the 4 to 700 range? So this is 550. How many SDs are we in either direction? This one, if SD is 100, how far is it to the right? 1.5. And then this is 1.5. Now, we can use A104 here. You could do shade norm. So shade norm, your lower would be negative 1.5, your upper would be 1.5. But page 104 will actually tell you in this case. So 104, we go to 1.5, and we get 86.6. Okay. B, there were about 1,000 students with scores in the 450 to 650 on the verbal SAT. About how many of them had scores in the range from 500 to 600? Ooh, that's a good question. So what percentage would we expect between 450 and 650? That is one SD up and one SD down, so there should be 68%. Okay, so if I bring it in a little bit from 600, or no, sorry, from 500 to 600, that's 0.5 SDs on either side. So we go to A104, we look up 0.5, and I get 38.29. Hold on a second. What does that number tell me? This is the percentage, right? Okay, well, we want a number. So I guess you could say about 38.29, but if 1,000, so here is z equals 1 and z equals negative 1. And here's x bar. 1,000 kids landed in there, right? So how many kids took the test? Well, 68% of them equaled 1,000 students, right? So the total times 0.68 equals 1,000. Go away. There we go. How many kids were there? Well, if t times 0.68 is 1,000, how do I solve for t? Divide. So 1,000 divided by 0.68, there were a total of 1,470. Okay. Now, what am I looking for? How many of them fit in this narrow z equals 0.5 window? It's 38.29 of the total 1,470. So 0.3829. 563. So that's a good question. It's kind of hard to figure out, but yeah. Yeah. Well, we've covered everything. You just have to do a lot of thinking. All right, number 5. In cycle 3 of the health examination survey, like Haynes, but done in 66 to 70, there were 6,672 subjects. The sex of each subject was recorded at 2 different stages of the survey. In 70 cases, there was a discrepancy. The subject was recorded as male at one interview, female at the other. How would you account for this? So how do you deal with people who were counted as male on one survey and female on another? Throw them out. That's what I would do. You would just throw them out. Is that going to mess things up? It might, but we don't really have a choice, right? The people are dead now, so we can't go back and ask them. All right. Among certain students at a certain college, the men averaged 650 on the math SAT, and their SD was 125. The women averaged 600, but had the same SD. There were 500 men in the class and 500 women. For the men and women together, the average SAT score was. Why is it going to be halfway between 600 and 650? Nope, not. It doesn't have anything to do with the SDs. There are just as many men as women. So what this question is saying is, if the female average is here and the male average is here, so 600 and 650, why does the new average end up at 625? There are an equal number of men and women. What if there were more women? The average would be lower than 625. Yeah, we're not sure about we don't know about the spread because the average doesn't tell us the spread. Okay, B, for the men and women together, was the SD of the math SAT scored less than 125, just about, or more than 125? More. So the reason is we're going to end up with, let's assume it's a normal curve for females and a normal curve for males. When I add those together, then my new one would look something like that, and the SD is going to be much larger because we have more spread. Repeat exercise 6 when there are 600 men in the class and 400 women. So if you repeat that, then the average is going to be slightly more than 625, and the SD is going to be still bigger than 125. Okay. Table 1 on page 99 reported 100 measurements on the weight of NB10. The top panel in figure 2 on page 102 shows the histogram. The average was 405 micrograms and the SD was 6. If you use the normal approximation to estimate how many of these measurements were in the range 400 to 406, would your answer be too low, too high, or about right? So the average is 405 and the SD was 6. If you use the normal approximation from 400 to 406, would your answer be too low, too high, or about right? If it's normal, it should be about right. It should be about right. So if it's normal, then we should be able to use the normal curve to estimate how many there would be. Now, chances are it's going to be off by a little bit, but if the curve is normal, we're going to assume that it should be about right. 9. A teaching assistant gives a quiz to his section. There are 10 questions, no partial credit. After grading the papers, the TA writes down for each student the number of questions the student got right and the number wrong. The average number of right answers is 6.4 with an SD of 2. The average number of wrong answers is what? Should be 3.6 with an SD of? So will the spread of the wrong be bigger, smaller, or the same as the spread of the right? Should be exactly the same, because for every, so let's say that's how many you got right and that's how many you got wrong, right? This is right and this is wrong. 2. The SD would be 2. So the SD measures spread. Okay, and the answers correct will be spread exactly the same as the answers incorrect. Does that make sense? Okay. Do you need the data? No. A large representative sample of Americans was studied by the Public Health Service in the Health and Nutrition Examinations Survey. The percentage of respondents who were left-handed decreased steadily with age, from 10% at 20 years to 4% at 70. The data show that many people change from left-handed to right-handed as they get older. True or false? False. What do you think is going on? Okay, maybe the left-handed people die sooner. I didn't think about that. I think there's something else at work. Well, it's different ages. So they measured a cross-section, and they noticed that there were fewer left-handed people when they're older than the younger ones. Well, so it's asking, did people change from left-handed to right-handed? My answer would be no. What did you say? So, right. My guess would be we are more accepting of left-handed people than we used to be. And some left-handed people were forced to be right-handed people a long time ago, and we just don't do that anymore. That would be my guess. Yeah. All right, 11. For a certain group of women, the 25th percentile of height is 62.2. The 75th is 65.8. The histogram follows the normal curve. Find the 90th percent of the height distribution. Wow, that's a tough question. Which I don't have time to answer. How would you find that answer? So let me show you how you do that. So the 25th is 60, what was it? 62.2, and the 75th is 65.8. So that's 50% of the data. So you find the difference, and then find the SD and cut the SD in half. Well, I guess no. So you're going to find the z-scores, and then the average must be halfway in between those, right? And using that, you can find the SD. And then once you have the SD, then you can find the 90th percentile.